You open your phone to check one notification. 90 seconds later, you're somewhere else entirely. A different app, a different thought. You don't even remember deciding to leave. You just left. Most people call this a broken attention span. But the real answer is far stranger. Your mind isn't malfunctioning. It's doing exactly what it was built to do, thousands of years before screens existed. Think about that for a moment. Your brain didn't evolve in a library. It didn't evolve in an office or a classroom or a quiet room built for focus. It evolved outside in tall grass, under open sky, where staying focused on one thing for too long could get you killed. A mind that locked onto a single task and ignored everything else was a mind that missed the rustle in the bushes. It missed the shadow crossing the water. It missed the moment it needed to move. So your ancestors survived by doing the opposite of focusing. They survived by scanning. Anthropologists call this behavior vigilance, and it wasn't optional. It was constant. Every sound demanded a check. Every movement at the edge of vision pulled the eyes toward it, whether or not the brain wanted to look. This wasn't distraction. This was defense. A human who could stay locked on a task while a lion approached from the side didn't get a second chance to learn the lesson. Here's where it gets interesting. Researcher Joshua New, working with evolutionary psychologists at Yale, ran a series of experiments testing how quickly people notice animals in a scene compared to inanimate objects, even when the animals are irrelevant to the task. People spotted animals faster, much faster, not because they were told to look for them, because some older part of the brain was already looking all the time without being asked. That part never turned off. It's still running right now, underneath every thought you have today. Now picture a modern room. No predators, no open plains. Just a desk, a screen, and a task you're supposed to be doing. Your ancient scanning system doesn't know the room is safe. It doesn't know the notification sound isn't a branch snapping behind you. It just knows something changed. And change used to mean danger or opportunity or both. So it pulls your attention toward the new thing. Every time, whether the new thing matters or not. This is why silence in a room can feel almost unbearable if you're used to noise. This is why a phone buzzing on the table feels louder than it should. Your brain isn't reacting to the phone. It's reacting the way it would react to anything unexpected in an environment where the unexpected once meant survival. You didn't lose your ability to focus. You inherited a system built to interrupt itself on purpose. Psychologist Daniel Berline described something similar decades before smartphones existed. He studied what he called the human drive toward novelty, the pull toward anything new, uncertain, or unresolved. Berline found that novelty itself activates reward pathways in the brain, almost independent of whether the new thing is useful. A new sound, a new object, a new piece of information. The brain treats newness as valuable because for most of human history, new information often was valuable. A new plant might be food. A new sound might be a warning. Missing something new could cost more than a mild inconvenience. It could cost a life. So imagine for a second, two early humans. One stays completely absorbed in a single task, undisturbed by anything around her. The other constantly breaks focus to check her surroundings. Which one is more likely to notice the predator circling from behind? Which one is more likely to still be alive next season to raise children who inherited the same habit? This is natural selection, quietly building a mind that can't stay still. Now bring that mind into an office building 300,000 years later. Your brain is still running the same ancient software, but the environment underneath it has changed almost instantly, at least in evolutionary terms. There are no lions here. There's a notification, a Slack message, a headline, an email subject line written specifically to look urgent, and your attention system, still tuned for detecting sudden threats and unexpected opportunities, treats each one the exact same way it once treated a snapped twig in the grass. Here's the twist most people never consider. This isn't a flaw in your design. It's a mismatch between your design and your environment. The circuitry itself is working perfectly. It's just responding to a world it was never built to live in. Neuroscientist Earl Miller, who has spent decades studying attention and working memory at MIT, has pointed out something that reframes the entire conversation around focus. The brain, he explains, was never built to sustain deep, unbroken attention for hours at a time. It was built to shift attention rapidly between multiple sources of relevant information, almost like checking mirrors while driving. That shifting isn't weakness. It's a feature, refined across an evolutionary timescale, where staying alert mattered more than staying still. So what changed isn't your brain. What changed is the sheer number of things now competing for that ancient scanning instinct. A modern person can be exposed to more novel stimuli in 10 minutes online than an ancestor might encounter in an entire week outdoors. Every scroll offers something new. Every new thing pulls at a system built to chase newness. Of course, it feels impossible to sit still with a single task. You're not fighting laziness. You're fighting millions of years of finely tuned survival instinct, dressed up as a to-do list. Does this mean you're powerless against it? Not exactly. Understanding where the pull comes from changes how you respond to it. When you feel the urge to check your phone mid-task, that isn't proof that something is wrong with your willpower. That's your ancient scanning system doing precisely what kept your ancestors alive, misfiring in a world of infinite tabs instead of open savanna. The urge is real. The threat behind it isn't. Some researchers studying attention restoration, including environmental psychologists Rachel and Stephen Kaplan, found that certain environments actually calm this scanning instinct instead of triggering it. Natural settings, they discovered, allow what they called soft fascination, a kind of attention that engages the mind gently without demanding the constant vigilance a screen full of competing signals requires. Time in these environments didn't just feel relaxing. It measurably restored the ability to concentrate afterward. In other words, the same mind that gets pulled in 12 directions by a phone can settle, quiet, and refocus in an environment that resembles the one it evolved in. That's not a coincidence. That's the mismatch correcting itself, if only for a while. So the next time you catch your attention sliding away from a task, notice what's actually happening beneath it. That isn't a broken mind. That's an ancient one. A mind built to notice movement in the grass now notices movement in a feed. A mind built to catch the rustle of danger now catches the buzz of a phone. The tool changed. The instinct didn't. Maybe the goal was never to silence that instinct completely. Maybe it's to recognize it for what it is, an inheritance from every ancestor who survived by never fully looking away. Tonight, when your attention drifts for the 10th time in an hour, you won't just see a bad habit anymore. You'll see something older than any screen, still doing its job, in a world that stopped needing it quite the same way. Consider how strange this actually is. You live in the safest environment your species has ever known. No predators wait outside your door. No sudden storm threatens to strip away your food supply overnight. And yet the part of your brain responsible for scanning for danger has never once been told to stand down. It doesn't take instructions from your calendar. It doesn't know the difference between a real threat and a headline written to look like one. Think about the last time a notification made your stomach tighten before you even opened it. That reaction happened in a fraction of a second, long before any conscious thought caught up. Your body responded first. Your mind explained it after. This order matters. It tells you something important about how deeply this instinct is wired. It isn't a habit you picked up. It's a structure built into the architecture of attention itself, inherited the same way eye color or height gets inherited. Now think about how modern life is designed. Nearly every app, every headline, every video thumbnail is built by people who understand this ancient scanning instinct better than you do. They know a red notification badge pulls the eye the same way a flash of movement once pulled the eye of a hunter-gatherer. They know an unfinished thought, a cut-off sentence, a video that ends mid-question, taps directly into the same drive toward resolution that once helped your ancestors track a wounded animal until the hunt was finished. You are not simply distracted by accident. You are being met exactly where your oldest instincts already live. This raises an uncomfortable question. If your attention was built for an environment that no longer exists, what happens when that environment is replaced by one engineered specifically to exploit the same wiring? Here's a way to picture it. Imagine an early human ancestor standing at the edge of a clearing. Something moves in the trees. She turns her head instantly before she even decides to. That reflex isn't laziness. It's a survival mechanism finely tuned across hundreds of thousands of years. It has to be fast. It has to override whatever she was doing a moment ago, because hesitation could mean the difference between noticing a predator in time and not noticing it at all. Now imagine that same reflex firing every few minutes, all day, every day, in response to a phone screen instead of a moving branch. The reflex hasn't changed. Only the stimulus has. And because the reflex was built to prioritize speed over reflection, it doesn't pause to ask whether the new thing pulling at it actually matters. It simply reacts. This is the mismatch at the center of everything. Not a personal failure, a timing problem between an ancient brain and a world that changed too quickly for evolution to catch up. It helps to understand what your attention was actually optimized to do, rather than what modern life expects it to do. Deep, uninterrupted focus on a single task for hours was never the primary goal of the human attention system. Constant environmental awareness was. Your ancestors who survived long enough to pass on their genes weren't necessarily the ones who could concentrate the longest. They were the ones who noticed the most, the fastest, without needing to be told to look. This reframes something people often treat as a personal weakness. When you struggle to read a long paragraph without your mind wandering to something else, you're not failing at attention. You're succeeding at exactly the kind of attention your brain was shaped to prioritize, applied to a task it was never designed to protect. There's a deeper layer here too, one that goes beyond simple vigilance. Anthropologists studying hunter-gatherer societies have noted that survival often depended not just on noticing threats, but on tracking multiple moving variables at once. Weather patterns, animal migration, the location of other group members, the condition of tools and shelter. A mind capable of holding several loosely connected threads at once, ready to shift focus the moment one thread became more urgent than another, had a clear advantage over a mind locked onto a single narrow point. In many ways, what looks today like a short attention span may actually be the echo of a mind built for managing many priorities simultaneously, rather than one long, uninterrupted line of thought.